All right, let's look at part B. So what we're going to do is to convert this form of the equation to the standard form of the equation of an ellipse. So we're going to write it as either like this way, where the major axis is horizontal, or this way, where the major axis is vertical. So let's try to first convert that equation by using completing the square, because as you see that all of the powers here, all of the terms here are completed the square, right? So let's go back and try to have the completion, the square. Oops. There we go for this equation here. So we have two different terms here, all x-related terms, x squared and negative 6x, and y-related terms. So we're going to have two different completion to square. Okay. So here we go. So I'm going to write x squared minus 6x here, and I'm going to write 10y squared plus 20y here. Okay. So for the first one, what I'm going to do is I'm going to put an x here and get the half of this coefficient here, and then take the quantity square, and I'm going to compensate this by the square of the last term. So I'm going to subtract the square of the last term from this. Okay. And for the next one, well, first I need to factor 10 out. I just get that out of the way. So I'm left with y squared plus 2y here. When 10 is out, I'm going to get the half of this coefficient added to y. Okay, so it becomes y plus 1 quantity squared, and this is compensated by the square of the constant term, which is 1. So I just subtract that. Okay. All right, so let's bring everything together. So I have x minus 3 squared minus 9 plus 10 y plus 1 squared minus 10, taking care of all underlying terms up in the equation. Plus 18 is equal to 0. Okay, this implies that x minus 3 squared plus y plus 1 squared. I have negative 19 plus 18, that's negative 1. And I'm going to add 1 to both sides of the equation at this level, so that I'm going to have a 1 on the right-hand side of the equation, which is in fact aligning with the standard form of the equation of an ellipse. And since there's no rationality here, I'm going to put a hypothetical 1 here, and maybe a hypothetical 1 here too. Okay. Oh, sorry, I don't have the hypothetical 1 because we have 10 here. Okay. So instead of that 10, I'm going to sort of like write that as 1 over 10. Okay. So 1 over, in fact, radical 10 squared. Okay, so because we want to make it look like x minus 8 squared divided by a squared plus y minus k squared divided by b squared, right? So the 10 in front of the coefficient of y plus 1 quantity squared doesn't look good, doesn't fit in the standard form, so we had to write that in this way. Okay. Also, I'm going to rewrite this as y minus 1, so that in one shot I can grab hk and b. Okay, let me just continue from here. I'm going to have an h to be 3, okay, and b to be negative 1. Sorry, k to be negative 1, okay, and a to be 1, and b to be 1 over radical 10. And remember that a is supposed to be greater than b, so that's why I called a to be 1. Okay, all right. So from the relationship c squared equals a squared minus b squared, I have 1 minus 1 over 10. That is 9 over 10. So that's plus minus 3 over radical 10. Okay, that's good. We have ABC, HK, and now we need the eccentricity, and as well as the location of the foci and the vertices. Okay, so let's try to clean this up, and let's get this let's see, which one do I want to get first? Obviously, the center. Okay, center is the easy one. Without having the center, you can't really proceed. So center is h and k, right? So 3 and -1. Okay. And foci, each focus is like, let's see, c units far from the center. Okay, so we're talking about like a being 1 and a is greater than b. A pops underneath x related terms. So here the major axis is horizontal, so we're going left and right to find the coordinates of foci. Okay, so here we go. So we're going to have 3 plus 3 over radical 10, -1, and 3 minus 3 over radical 10, minus 1, to be the coordinates of foci. Okay. And for the vertices, we are a units far from the center. So a is, let's see, 1. A is 1. Yeah, here we go. So essentially 4, -1, and 2, -1. Again, to the right, to the left from the center with the distance of like 1 unit. Okay. All right. So, and finally, we need to write the eccentricity, which is c over a. And c equals, let's see, 3 over radical 10 plus 1. Okay, that's 3 over radical 10. Okay? I think we have all the ingredients right now, and all we want to do right now is to double check if we got everything sorted out. Please have your TI-84 with you and try to plot this equation, okay? And see what you come up with matches with what we have in the plot. Okay, so here's my plot. So I have a very flat ellipse because the eccentricity is very close to 1. Okay, we have the center located here, right? And then foci and vertices are very close to each other. See the brown and green points over there? That means that C is very, very close to 1. And when C is smaller, then the ellipse turns out to be more circular. Okay, so I think that's all at this point. If you have any questions or comments, please send those to my way, and I'll see you in another video. Bye.